Yeah, so today I'm just going to be starting my journey learning machine learning with Python, and then eventually I will branch out. I will start learning machine learning with R, and we will soon know machine learning in a couple of different languages. But right now we're just going to learn it with Python, and currently I'm using Data Camp's course um, for like being for ML for being an ML scientist, and yeah, we're just starting out by learning the different packages, and the first course that I'm looking at right now is supervised learning with sci-kit learn, and then we'll continue building it up uh for a couple of weeks until we learn like an entire repertoire in Python, and then we'll start branching out towards R and stuff. And yeah, I'm just taking some notes on all the videos, and then the exercises are of course going to be on that site, but I will try to add my own versions and save them in Python files under a folder, and push it to my GitHub, where it will then be available for everyone to view.
Which
But
makes the workflow repeatable.
right now I'm just getting some stuff on the syntax for scikit-learn. But yeah, essentially what I have so far is I have what machine learning is, what supervised and unsupervised learning is, and different types of supervised learning. So it's classification models and regression models. And then now I'm getting into scikit-learn and its syntax, so I can start using it for supervised learning.
Let's familiarize ourselves with the general scikit-learn workflow syntax before we explore using real data later in the chapter.
Yeah.
We import a model, which is a
Um,
type of algorithm for our supervised learning problem from an sklearn module. For us to predict instantiate the model, and the target is learn model, which is using algorithm for our supervised learning.
I wonder how to oh, this is that. Just capitalize that. Yeah. Yeah, this basically. I'm gonna bold this whole thing. not sure how good this explanation is, but this is what I understand from it. And then
learning problem from an we create a variable,
and then you basically then you basically you create a variable you create a variable and you basically assign it to some function. And so this variable model, you will create some function with model with an uppercase M, and within that function you will describe, like, how your model works. And so then when you have to call your model, you can just, or when you have to do any sort of math with your model, then you can just use this variable and it will call that function
named model, and instantiate the model. A model is fit to the data.
Creates a variable that is assigned to a function for your ML model that will be assigned to a function where you will mathematically describe the model. And now you then you just I think this is what it is. Oh, big X, little y. And the reason why we use big X and then little y is because it's because there's, I'm pretty sure, because this is what's it called? This is an explanatory variable and this is a response variable. So because this y is predicted, it's lowercase. And because this x is essentially a set of, this x is a vector. So this x is not just one x value, it's a vector, so it represents a space or a set of x values, which is why it's represented by this big X, because this is your independent variable and is not we are representing multiple different values underneath one vector space. This with this X, and this model will sort of fit a relationship between predicted Y and this vector,
where it learns patterns about the features and use the model's dot predict.
Learn patterns. Relationship between predicted response variable and vector. Just add this because it is a vector of values. So I'll just it's a new line. And yeah, now we essentially make a prediction. I don't know how correct that note is. Um, I'm just adding some additional notes in the video based on the transcript that I didn't get. I don't know why this is a little K like this, but anyway. Yep. Just to fit the data, we use mobs to X an array for future. Okay, technically vector is a math term. I'm a math major, which is probably why I'm doing this, but it doesn't, from a computer science standpoint, it's really an array, but it's mathematically a vector, so. But yeah. Yeah, and they use this example of spam, and yeah, we already told this was binary classification because there's either fraudulent or non-fraudulent. So if the predicted values are one, then the email is fraudulent. Otherwise, it predicted values will be 0, and this will indicate that the emails are non-fraudulent. This is basically how binary classifications work. Just like binary is a 1 means there is a correlation, 0 means there isn't. Oops. Cool. Yeah. Oh, I actually got this wrong. Actually, now I look back on it, I think we use a capital X because it is a matrix of values. So multiple vectors belong with each column as a new vector in the matrix. Yeah, so each column is a vector. So x is actually a matrix. So it contains numerous vectors where each column is a vector, whereas y is a vector. Yeah. And so then it will use these to create so x is actually a matrix and y is a vector. Anyway.
To a spam classification model, an array of 6 values is returned. A 1 indicates the model predicts that email is spam, and a 0 represents a prediction of not spam. Now let's check our understanding of supervised learning and how to perform it in sci-kit Learn.
Okay, so okay, now I'm just going to add the notes. Yes, I'm wrong with it. Oh, no. Let me see if I can pull up the terminal. Okay, add. Okay, isn't this? Oh, add origin. My bad. What? I'm surprised this isn't working. Oh, right. I might not have Git installed yet. That's probably why. It's okay. I'll just do it the manual way. Um, let's see. Yeah, it should be in now. Yeah, it's in now. It's in my GitHub. The notes are there. Yeah, nice. Oh, um, do I need to create new paragraphs for every single one? Is that why? Well, it's not supposed to be a heading. Let me try. Let me get rid of this file and actually I'll just edit the file now. Then I'll just okay, yeah, there we go. Yeah. Okay, so now it's in. Yeah, we are all good. Yeah. So now we're just gonna answer some questions and then I'll head off and we can pick this up. We can pick this up tomorrow. Let's answer a few quick questions. Yep, changing the scene. There we go. Okay, so let's look at these. There are two types: classification regression. Binary classifications used to predict a target as two labels. The head of a data set, churn. Are these? Okay, I don't remember what churn is, but this is like, I think I've seen something similar to this before. It's like, yeah, I don't remember what churn is off the top of my head, but there's like, I've heard of it before. But anyway, the head of a data set is shown below. So obviously this is part of the library. This is part of the library or the module for scikit-learn. But anyway, you can expect the rest of the data to contain similar values. Looking at this data, which column should be the target variable? Hmm. Oh, it tells you up here. Is used to predict a target variable that has only two labels. Wait, no, it doesn't tell you. Okay, so the data is called churn. So I would assume that you're trying to predict churn based on based on these values, right? So the target variable, if we go back to our notes, we wrote that the target variable is also like referred to as the dependent variable or the response variable. So that's what we're trying to predict. So I would assume that's churn. Now I don't know what we're exactly trying to predict it on, but that's not the point in question. Um, so recall that scikit-learn offers a repeatable workflow for using supervised learning models, and so they just want us to reorder the pseudocode so that it accurately represents the workflow. Now they just covered the workflow in the video. They covered a bit of the syntax. So first you have to import the module. Then you can then within the module, from that module you import the model, and then you have the model, and then you've got to fit the values, and then using the fitted values you've got to predict new ones. So I would assume that's it. Yes. Yeah, okay, I'll cover this in the next video. So this should be all for now.